Okay, we're now going to start the second video, working through the homework review for the final exam. Ready now for problem 3. And now we're going to start some problems, solving inequalities. For instance, number 3, they ask us to solve this x squared plus 2x greater than or equal to 3. Now let me take just a brief minute and let's talk about solving inequalities. Actually, on the first exam, we actually started working on solving inequalities, except they were linear inequalities. For example, something like this maybe. 2x plus 1 greater than 4x plus 3. Now the way we call this a linear inequality because these are linear expressions. There's no exponents on the variables. The way we solve a linear inequality is just we get x by itself on one side. So in this case, I would subtract 2x from both sides, subtract 3 from both sides, divide both sides by 2, or we could write this x less than -1, and that's the solution. Of course, here it's different because now we don't have linear expressions. Now we have, in this case, it's a quadratic. And we could even have higher exponents that we have to solve. So the method we used over here, we cannot use the same method here. To try and get x by itself on one side doesn't make sense because I have an x squared term and an x term. I can't get x by itself on one side. So instead we have to go about a different method to solve this. What I want to do, just to help you, and the way I'm going to show you, when I looked at the book, I don't think the book does it this way. The book to me is a little more confusing. I'm going to show you a way today that I think is pretty practical, and once you get the hang of it, it's not difficult to use. So what I want to do is, let me just write down the steps you go through. And initially, of course, these steps may not make a lot of sense, but as we do the next 2 or 3 problems, hopefully you will get the hang of it and use it if it helps you. If you've got another way to solve these, then by all means you can use that. So let me just go through these steps real quick. First step, and I'm going to use very simple language for these steps. Get everything on one side. In other words, one side should be 0. In a minute, when we do this problem, I've got to move through the 3 to the other side. I'm going to subtract 3 from both sides. The only way we can solve these kinds of problems, you have to have one side equal to 0. Then once you do that, you look at the expression you have, and you have to factor it. As a matter of fact, if the expression doesn't factor, then we're going to be sort of stuck, and we can't really solve it, at least in an easy way. So it's going to have to factor. So next you factor, and then, now this may not make any sense till we go through it. I'm going to say find the zeros, and just so you know, we're going to take that expression and we're going to find the values of x that would cause the expression to be 0. So we're going to try and figure out the values of x that would cause the whole expression to equal 0. And we'll do some examples of that in a minute. And then use the zeros to we're going to use those zeros to mark up a graph, and you'll see when we do that, you'll see that we're going to break up this graph into what we call regions. This will all make sense as we do it. And then we're going to do something called, we're going to create a sign chart, which you may or may not be familiar with. And then after we create the sign chart, we basically are able to solve it. All right, so this may seem complicated at first, but hopefully after we do a couple of these, not too difficult. So let's go ahead and solve this one, even though maybe you can't see the steps here. So the first step is always to get everything on one side. So I'm going to subtract 3 from both sides. Now let's take a minute and look what we have here. We have this expression, and we're trying to solve this. To solve an inequality means I'm going to try and find the value of values of x that make this inequality true. And in this case, I'm trying to find all the values of x that cause this expression to be greater than or equal to 0. So that's essentially what this problem is about. Let's find the x's, and in this case, it's probably going to be an interval, or maybe multiple intervals. Let's find the values of x that cause this expression to be greater or equal to 0, or you know what else we can say when something is greater than or equal to 0? In a sense, we really want to figure out the values of x that cause this expression to either be positive or 0, right? Because whenever this expression is positive, that's what it means to be greater than 0. So at the very end, you're going to see me come back to this, where the whole key is, what are the values of x that cause this expression to be positive? All right, so first step, get everything on one side. We need one side to be 0. Second step, factor. This is a trinomial, and if we factor it, should be, how about positive 3 times negative 1? So how about x minus 1 all right, and like I said before, if these problems don't factor, we're going to be stuck and we won't be able to solve them. Now that it's factored, now we're going to find the zeros. So this is the factoring. Find the zeros. The zeros you've already done before, because the zeros, once again, are the values of x that cause this whole expression to equal 0. What values of x cause this expression to be 0? Of course, you notice what we have is we're multiplying 2 parentheses. So I can look at these 1 parenthesis at a time. If I look at this first parenthesis, what value of x would cause this first parenthesis to be 0? Because 0 times anything makes the whole thing 0. Well, obviously, if I look at that first parenthesis, if x equals 1, the first parenthesis is 0, the whole expression is 0. And if I look at the second parenthesis, minus 3 would cause the whole expression to be 0. We call these two values of x the zeros, because those are the values of x that cause the whole thing to equal 0. Now what I'm going to do is, over here, I'm going to start my, like a chart or a graph. I guess I'll call it a graph. Although really all I care about is x. I don't care about y so much. I'm going to go And on this, it's almost like a number line. Mark these points. So I'll say right here is -3, and right here is 1. And you notice what I do is, at each of those values of x, I sort of draw these dashed lines. What I'm actually doing, I'm actually breaking this number line or this graph up into regions. In other words, I'm going to call this region 1, which actually, if I look at my number line, from -infinity to -3, this is region 1. From -3 to 1 is region 2. And from 1 to infinity is region 3. So when I go mark my zeros of x right here and draw these lines, it breaks this up into regions. Now here's what we're going to now try and figure out, because here's the whole key to this working. Region 1, x is going to be between -infinity and -3. What happens is if I pick any value of x in region 1, in other words, I can pick -10, -7, -5, -4, all those values of x are region 1. If I put any one of those values of x into my expression, it's always going to be the same sign. It's either always positive or always negative. At this point, I don't know which it is. All I know is that every value of x in region 1, if I plug it into my expression here, is going to be the same sign. Then, if I go to region 2, which is between -3 and 1, any value of x I choose in region 2, in other words, -2, -1, 0, any of those values, if I plug those in for x, it's always going to be the same sign. Once again, I don't know for region 2 whether it's positive or negative, but it's not going to change. And then region 3 is the same way. Any value of x I choose between 1 and infinity, if I plug those numbers in for x into my expression, the sign is always going to be the same. So really my goal is I want to find out if region 1 is a positive or negative region. I want to find out if region 2 is a positive or negative region. I want to find out if region 3 is positive or negative. Because I know within the region it can't change. Now I just have to find out what each region is. And the way we find out what each region is, we create a sign chart. So here's how I do my sign charts. I'm going to create some columns. The first column is region. And I look at my graph, and I see my graph, I have 3 regions. So I put 1, 2, 3 regions. The next column, I'm going to call test point. What I do is, I go into each region, and I choose a value of x in that region. So for region 1, x's have to be between -infinity to -3. Now I cannot pick the point sort of on this boundary or this border. It has to be something actually in the region. For instance, for region 1, I'll choose -4. Now region 2, I need to pick something between -3 and 1. You know what's in here? 0's in here. I always like 0. We'll choose 0. Then region 3, I need to choose a test point. Has to be between 1 and infinity. How about 2? Now what I'm going to do here is I'm going to list, I go back to my factored expression, and I'm going to list each factor one at a time. Factors are things you multiply. I have 2 factors here, these 2 parentheses. So here's the first parenthesis, and here's the second parenthesis. And then finally, one last column. That's an OV, and that stands for overall. So here's what I'm going to do now. I'm going to go to my region 1 row. My test point's -4. what I'm going to do is I'm going to take this first factor here, and I'm going to plug in minus 4 in for x and see what I get here. Except I'm not going to write the actual number down. All I really care about is if I end up with a positive or negative number. So I plug negative 4 in for x here. Negative 4 minus 1 is negative 5. That means this whole thing is negative. So a negative 4 causes this to be a negative number. If I plug a negative 4 into here, negative 4 plus 3 is negative 1. It's also a negative. Now this last column overall, now you simply multiply all the signs that you've come up with so far. I have a negative times a negative. What happens when you multiply two negatives? You get a positive. Now, what I've discovered is region 1 is actually a positive region. I usually go back up to my chart, and in region 1, I put a plus. Now, what did we just learn? Here's what we learned. If I choose any value of x between negative infinity and negative 3, if I choose any of those values of x, and when I plug it in to either this expression or this expression, they're both the same, what's going to happen? It's always going to be positive. Every time I choose an x in region 1, and plug it into my expression, it's always going to give me a positive number. Let's go to region 2. Now, just out of interest, what happens when I plug negative 3 in? Well, negative 3 is my borderline, and this is a 0. If I plug in negative 3, the expression equals 0. So here it's positive. It goes to 0 at 3. Region 2, I don't know what it's going to be. Is it going to be positive or negative? Let's go to my sign chart to find out. So region 2, I've chosen 0 as my test point. I plug in 0 for x. 0 minus 1 is negative 1. So it's a negative. Plug in 0 into here. 0 plus 3 is positive. Overall says a negative times a positive is a negative. I've just determined that region 2 is a negative region, meaning any value of x I would choose between minus 3 and 1. If I plug that value of x into my expression, it's always going to be a negative number. Finally, region 3, my test point is 2. When I plug 2 into my first factor, it's positive. I plug 2 in here, it's positive. Two positives multiplied together is positive. Region 3 is a positive region. So let me say this. Once we finish the sign chart and we find out which regions are positive and negative, we're basically, for the most part, done. Why do I say that? Let's go back again to what I said at the beginning. What am I really trying to do here? I'm trying to find the values of x that cause this expression to be positive or 0. And you know what I've got here with this chart now? I know which values of x cause this expression to be positive. Region 1 is a positive region. Region 3 is a positive region. In other words, any value of x in region 1 or region 3 will cause this expression to be positive, which means it's greater than 0. So once I do the sign chart, I go back and confirm what I'm looking for, and then I'm pretty much done. So here's my solution. I'm looking for the positive regions. Turns out I have 2 regions that are positive. These are both going to be solutions. So how do I write that as an interval? Well, I'm going to write the interval for region 1, which starts at negative infinity and goes to negative 3. Now, so I put a parenthesis or bracket here. I go back here, and the solution is greater than or equal to. So when this expression is 0, that is also going to be a solution. Negative 3 causes my expression to be 0. I want to include negative 3 as a solution. So this interval is negative infinity to negative 3 with a bracket. But then I also have to include all the values of x in region 3 because it's also positive. So I'm going to union it. And I'm going to go to region 3. Once again, 1, the number 1, if I plug in 1 for x, the whole thing would be 0, which is part of my solution. So another bracket. 1 to infinity. So this is the solution to this problem. So here's the original problem. A quick review. I get one side equal to 0. I factored it. Once I factored it, I was able to find the zeros. And from the zeros, I made my little number line, my little graph with the number line, and found my regions. I then went, created my sign chart. The result of my sign chart tells me which regions are positive and negative. And once I have that information, I actually then can figure out my solution. All right. So hopefully you can think about that. And hopefully maybe you understand that, or if you've not seen it before, you can think about it, because I think it's a pretty good way to solve these. As a matter of fact, we have another inequality to solve. Problem 4, which is 5 times x squared minus 1 in parentheses greater than 24x. So now I'm going to go through the steps just like I laid out the last time. This problem hopefully will go a little faster. First of all, I need to get everything on one side. Let's move everything to the left-hand side, and I'm also going to go ahead and multiply out this parentheses, because I'm going to have to probably refactor this whole thing. So subtract 24x from both sides. Now if I sort of write this in descending powers like we normally do. So there we go. We have 0 on one side, everything else on the other side. Now we need to factor. Now I'm going to off to the side because this is not one I can just do in my head. My product is 5 times negative 5, so my product is going to be negative 25. This is how I factor these trinomials. My sum is going to be negative 24. So two numbers will multiply together that equal negative 25. When you add them, equal negative 24. I believe it's negative 25 and 1. So then I write the first term and the last term. And the middle term gets broken up into, let me go minus 25x here and plus x. Then I factor by grouping. I take these first two terms. There's nothing to factor here. I have an x minus 5. I notice I have identical parentheses, so I factor out the whole parenthesis. Okay, so what I'm doing now is just factoring. So when I get all done, there it is. So you have to be able to factor, of course. And this is how I do it. You may do it a different way. Now let's find the zeros. So the zeros are the values of x that cause this whole expression equal 0. First parenthesis, it's pretty straightforward. If x is 5, that whole parenthesis is 0. Second parenthesis is a little trickier. And sometimes if you're not quite sure like this, you can always just take whatever's inside the parentheses and set it equal to 0 and solve for x, just to make sure you don't make any math errors. So I'll subtract 1 from both sides, divide both sides by 5. So it looks like these are my zeros. So now, let's do my chart over here, or my number line. So I've got negative 1/5 here, and 5. So when I plot these two zeros, I draw the line, so break it up, it looks like I have 3 regions again. So now I'm going to create my sign chart. First is region, 3 regions. TP stands for test point. Region 1, let me choose -1. -1's in region 1. In region 2, I'm going to choose 0. In region 3, I'm going to choose 6. Now I need to list all my factors. I have x minus 5, and then 5x plus 1, and then my overall. So now I work out my sign chart. So for region 1, when x is -1, negative, x is -1, negative, 2 negatives multiply to positive. Region 1 is a positive region. Region 2, test point is 0, negative, positive, multiply these together, it's negative. So region 2 is negative. Region 3, if I plug in a 6 for x, positive, positive, 2 positives make a positive. Region 3 is positive. All right, so now that I figure out what my regions are, I'm pretty much done. I go back up here and look, what am I looking for? I'm looking for when is this expression greater than 0, or when is this expression positive. There are 2 regions where it's positive, region 1 and region 3. And this time I do not include the boundary points or the zeros because it's just greater than. So therefore, the solution is region 1, which is negative infinity to negative 1/5. So this is an interval. But region 3 is also positive, so I union it. I start with 5, and I go to infinity. And there's your solution. All right, I'm going to stop this video now. We have a couple more problems to do that are very similar with just a couple small twists, and we'll keep going from there.